So in this problem, we are given the equation of a parabola and we need to find out the coordinates of its vertex and the focus, the equation of the axis and directrix, and the length of the lattice vector. Let us begin. So what we'll do, we'll start with the given equation of the parabola and try to express it in the standard form. So here we have y squared equals to 4x plus 4y. Let's transpose 4y to the left hand side till we get y squared minus 4y equals to 4x. Now what we'll do, we'll try to convert y squared minus 4y into a perfect square by completing the square. That means we'll take y squared minus, rewrite 4y as 2 times y times 2, and this particular number 2 is the hint that we need to add and subtract 2 squared. So this will be equals to 4x. Now in doing so, the first 3 terms is going to become y minus 2 whole squared. This will be equals to 4x. So we'll transpose negative 4 to the right hand side to get positive 4. So here we have y minus 2 whole squared equals to 4 times x plus 1. Now this is the equation of the parabola, although it is expressed in the standard form, but the coordinates of the vertex has been shifted by some amount. In order to find it out, what we'll do, we'll transform the coordinates from x comma y to a new coordinate system x comma y using a substitution x plus 1 using equals to x in uppercase and y minus 2 equals to y in uppercase, such that equation number 1 now becomes y squared equals to 4x. Now this is quite similar to the standard form of the parabola y squared equals to 4ax, meaning the value of a is going to be equals to 1. Here we have a equals to 1. So we can use a equals to 1 and y squared equals to 4x to find out the coordinates of the vertex, the coordinates of the focus, the equation of the axis and directrix, and the length of the lattice rectum of this parabola. But what we'll do, instead of using this equation, we're going to use the transform equation y squared equals to 4x. And for this problem, what we'll do, we are going to use the graph of y squared equals to 4ax. So this is a right facing parabola. So here we have the graph of the parabola y squared equals to 4ax, and this is a right facing parabola. The coordinates of the vertex will be at the origin 0, 0. Coordinates of the focus will be a, 0. The line on which the coordinates of the vertex and the focus lie, that line is referred to as the axis of symmetry line. And for this particular case, since the axis of symmetry is along the x-axis, its equation is given by y equals to 0. Now, on the same axis of symmetry line, we have another point. This is the point through which we have a line that's passing through that point, and it is perpendicular to the symmetry line. So this line is referred to as the directrix line. Also, its position is very important. The distance of the directrix from the vertex is equals to the distance of the focus from that same vertex. And since the directrix line is parallel to the y-axis, so its equation is given by x equals to negative a. So negative a means it's passing through the point negative a, 0. And then we have the lattice rectum. So this is a line that passes through the focus of the parabola, and it is perpendicular to the axis of symmetry with its endpoints lying on the parabola. So its length is given by absolute value of 4a. Now what we are doing, this is the parabola in its standard form, and we have expressed it in terms of the new coordinate system x, y. So we are using the new coordinate system x, y. However, our goal is to transform it back to the original coordinate system, that is x, y. All we have to do is make use of these two substitutions. So we'll start with the vertex of the parabola. So here, the vertex of this particular parabola, so here a will be equals to 1. So when we have vertex of the parabola given as 0, 0, this simply means that the x value equals to 0 and the y value is 0. Now, what to do? In order to find out the vertex in the old coordinate system, we'll use the same equation, x equals to 0, but in place of x, we'll use x plus 1. So that means x plus 1 will be equals to 0. This gives us x equals to negative 1. And then we'll use the equation y equals to 0, but in place of y, we will use y minus 2. The y minus 2 will be equals to 0, so that gives us y equals to 2, which means that the coordinates of the vertex in the old system is going to be negative 1, 2. Next, coming to the focus. So the focus of the parabola is at a comma 0. So a is 1, so that means the focus is at 1 comma 0, which means the x value is going to be 1 and the y value, that's 0. So what we'll do, we'll use the equation x equals to 1, but in place of x we are going to replace with x plus 1. So this will be equals to 1, and then we have y equals to 0, which means y minus 2 equals to 0. So solving for x and y, we're going to get the coordinates of the focus of the parabola in the old coordinate system. So that's going to be 0 comma 2. Now coming to the equation of the axis. The axis is given by the equation y equals to 0. So we'll use this equation, and in place of y, we'll replace with y minus 2. So we have y minus 2 equals to 0, which means that y equals to 2. Then we have the directrix. The equation of the directrix is going to be given by, so here we have the directrix equation given by x equals to negative a. We have x equals to negative a. So what we'll do, we'll replace the value of x with x plus 1. This will be equals to a. So a value is negative 1, which means that x will be equals to negative 2. So this is going to be the equation of the directrix in the old coordinate system. Now coming to the length of the lattice rectum. So length of the lattice rectum will be equals to absolute value of 4a. Now clearly, here we don't have any dependence on x and y either from the new coordinate system or the old coordinate system. So meaning the length of the lattice rectum is going to be fixed in both the two coordinate system, because it talks about the shape of the parabola. So here we are only shifting the origin of the vertex of the parabola, which also changes the coordinates of the focus and the equation of the axis and directrix, but the length remains the same because the shape of the parabola is unchanged. So we have successfully obtained the coordinates of the vertex of the parabola. So that's at negative 1 comma 2. The coordinates of the focus will be 0 comma 2. The equation of the axis is y equals to 2. Equation of the directrix, that's x equals to negative 2, and length of the lattice rectum is 4 for the parabola. Y minus 2 whole squared equals 4 times x plus 1.